Right, so I'm still playing with my cheapo printer. I'm learning lots, which is it's good to learn lots, I'm sure. Um, so I've just tweaked it so I can get the build plate to heat up in enough time. So basically, the CTC heated build plate, you know, it's standard. It's printed on a printed circuit board, but the loop must be too long. So it's only drawing a couple of amps at 24 volts. So what I've done is added this boost converter, stepping up to 40 volts. So from 24 volts to 40 volts. I didn't think this little chip has 7R030 or something on the mighty board would be enough to power it. So I've added. So it'll do for a couple of FETs, paralleled up and driven by a PNP transistor. Google, the amount you can learn, brilliant. But I think kind of looking okay. Nothing's cooking yet. Yeah, so I kind of feel I need to do a bit of a product review. Apart from the heated build plate not heating up enough, I've also had to modify the resistance here of R65 because the output from the thermistor on the back of the board on the heated build plate was showing way lower, like 30 degrees lower than it was actually measuring at. It was a multimeter thermocouple thing. Not particularly accurate, but you know, 30 degrees is a world away. You know, I was really struggling printing ABS, just peeling off the build plate, and the reason was because the build plate was stone cold because it wasn't heating up because the thermistor was wrong, and then when I tried to heat up, the processor was timing out. So yeah, CTC printer, the opportunity to learn a lot, and I've still got to figure out what to do about that noisy little fan. A beast. It's a beast. Rab. Useless fluffiness. And I've bought a new pulley for the Z-axis controller, and hopefully that's enough. And if necessary, I'll also buy the belt for the X-axis drive. I had one of these in stock already. A little eBay boost converters. Maxed out the current and turned the voltage up to 40. Right, that's my little rant over. Turning into a bit of a geek now. Quite like it, learning about the tools you're using, but whether or not it's actually necessary. You know, such as get what you pay for. I guess some people pay for an education, and I paid less for this education, so yeah, swings and roundabouts. Ah, it's working, and nothing's burst into flames yet. Result. Yeah. Right, my CTC printer. Keep forgetting the list of things that I've had to tweak to get this to work. So first of all, it was the firmware not updating. I'm guessing they deleted the bootloader on the mega processor. That's my I don't know. I tried for a few hours to try and get it to update normally, and it didn't work. So I had to update it with a serial programmer. And then I've got it written down here. There was that stupid fucking counter, the USB stick thing here that went into the side and went into the UART channel on the mighty board, that was trying to count the filament that I was using, and it was going to try and make me buy filament from CTC, which I thought was way off given the open source nature of the printer. And then the X-axis inaccuracy. I still haven't put it in. I bought some new pulleys for the X-axis. You can see it when you move it. If you can see that. But here you can see the belt moving up and down, like it's kind of pulleys oval or something. And the same at this side here. So we'll see if this sorts it. I've just done a software fudge at the moment, adjusting the steps per millimeter. I haven't actually managed to print anything with the dual head there. I've only been using the right extruder. And when I did try to do one print with a dual print with support filament in the left. It went to this side and then started crunching horribly, like it was overstepping. I guess there's some. It might be down to the x-axis adjustment I put in, or there might, I guess there's a setting somewhere to say how many steps maximum that way is. But that's still to be figured out. It was lost the thermocouple sensor output for the second extruder as well, and it looks, when I put it on the build plate, that this extruder nozzle is like 2 mil above the other one. I assume they need to be exactly the same so you can print on the same level. So that's possibly more learning to be done. And then the build plate not heating up, so I was really struggling with printing ABS. So I got it working now, and it's stick pretty well. By putting an extra resistor, so changing the value of R65 on the Mighty board to, like, I think it was 2K or something, anyway, paralleling it up with the resistor that's on the heated build plate, which it's just a voltage divider between that resistor and the thermistor that gives the feedback to the Mighty board to know what temperature the plate's at. So by adding another resistor in series with that on the board, it makes it think that it's the right temperature. I don't know if it's a bad thermistor or if it's the wrong value. It did seem to be a 100K thermistor. Maybe just got the wrong curve, I don't know. But it seemed to work well enough. Still about 10 degrees cooler than it should be. I might add a lower value resistor in there and see what happens. I've ordered a infrared thermometer so I can get more accurate measurement of the build plate. And then the power of the build plate. When I fixed the feedback, so I got a more accurate idea of the temperature of the build plate, it was timing out before it was able to heat up the build plate, and like ambient was 20 degrees, and then it wasn't able to maintain 120, 130 degrees on the build plate, because it was drawing a couple of amps at like 50 watts or something, which is no good, because the build plate area was just cooling down way quicker than it could heat up, which meant the temperature was dropping. I had to cover it with a little blankie while it was heating and to get it to go. So I've stepped up the voltage with the DC-DC converter, boost converter, the 400 watt one. So now it's drawing about 5 amps at 40 volts. I'm guessing the resistance in these loops here was just too high for the 24 volt power supply, and it wasn't drawing enough current to sink enough power into the plate to heat it up. So by turning up the voltage, we've increased the power. The power supply was rated for like 14 amps at 24 volts, so that should be fine. It's about like 300-400 watts. 300 watts? Yeah. So the build plate's now drawing about 200 watts, and it seems to be fine. Obviously with the FET controller, using the output from the logic level FET on the Mighty board through a PNP transistor to another N-channel FET paralleled up without heat sinks, and that seems to switch on the DC-DC converter fine, and then that is plugged into the board. Yeah, so it's getting there. Obviously still more tweaking and playing to do. As I say, it's all education. The crazy idea is I've been on this bit of a end cap mish of actually printing the end caps in ABS. So this is a solid print ABS of acetone. Schmood it. So I just put some acetone and rolled it about for a bit and put it in a vaping chamber with some acetone and a little computer fan to smooth the outside. And it makes it nice and shiny and smooth. And the idea of this is going to be a 3D printed end cap, so I've actually printed it on the printer rather than using it as a mold. So the dome shape will hopefully keep all the force in compression. Like a lot of materials, I think printed ABS is tends to go along the lines, so any kind of tensile force is going to be a weak spot. That's why I put the O-ring seals on the outside of the tube, so they kind of should squeeze in. I've ordered some more O-rings to go in that groove there, so it'll be a double sealed one. I thought I might as well put one in on the ends of the tube like that, and then there'll be another one on the inside. So that kind of looks pretty promising, because the acrylic dome it was only like a mil, 2 mil thick, so I left this like 3 mil thick at the top here. It's obviously thicker here around the edge to support the those pretty chunky O-rings. It's a 5 mil cross section O-ring, which means I like the 5 mil because you get more. It's more forgiving, I think. You get your compression percentage on the O-rings a lot more forgiving, and obviously there's quite a lot of roughness, cuts, and pretty DIY at the moment. So to have a bigger O-ring allows me more inaccuracy, and it should still seal. And we'll see how much this plastic can take. This first print, they weigh about 80 grams. I used about 80 grams of filament, and it took about 4 hours to print. 100% fill, and I just turned up the shell count to like 25 or something. So it just keeps going round and round and round. It doesn't bother going backwards and forwards filling in. Which looked alright. There's a couple of bits where the shells, where the lines didn't actually line up. I guess that's a flaw that goes into the mould quite far, and there was one here, and there was one up here as well. Don't know what's that about. So I still haven't enclosed this printer, so it might be a temperature thing. It might be under extruding because this filament's 0.7 instead of 0.75 millimeters. Yeah, but I quite like. I'll test these as soon as I get the O-rings. Quite excited about that. Maybe you could print them off without the dome and just leave a space for a disc of acrylic like the Blue Robotics housings, and screw them in, and maybe some external way of clamping them together, bolts or something. You could add lugs, or you could use smaller O-rings. You could have the 2 O-rings in line. Yeah, lots to play with. But yeah, endlessly playing with end caps. Quite like to get the ROV done and actually get something in the water. But that is quite good. I'm quite pleased with that.